Okay, hi everyone. We are looking at a early design review of new functionality for showing fits along with plots.
I was going to say design review
I know. I
is
think this is
yeah,
very
It's the brainstorming
pre-design
meeting.
review.
Okay, good.
exactly.
Yeah, it's not.
Okay, all
This
right.
is a gathering of thoughts.
Yeah.
Okay. So let me tell you what, as far as I'm concerned, is an important thing. Okay.
Hmm.
You know, I have some data, like let's say I've got um, I don't know, let me make some data, okay? Let me say table of, I plus zero point 0.1 random real minus one. Oh, that's a stupid way to do it, but anyway, never mind. Uh, I goes up to 100, let's say. Okay, and then let's say list plot this. Okay. Ah, silly me.
I can guess a model for that. And that one too.
Okay, there we go. All right. So a thing that I really often want to do is to take this. Oops. Dear. Where am I putting this? This is um, okay, it's going into visualization fit plots.
Okay.
Okay, the thing that I so often want to do, I've got this. Let me show you the horrifying workflow. Okay, so now I say find fit of %5, comma, a plus bx, ab x.
Isn't it vars and pars? Oh.
No, that's what it is, and that's beautiful, right? But now, how am I going to use that? Well, what I have to do is I have to copy this, paste it in, say slash dot %6. It's grotesque. You see what I'm saying? And then I want to take this. A very common thing that I want to do is I want to say plot that line 7 there. Plot that x goes from, I have to remember where it went from, 1 to 100 there. And then I want to say show %4, comma, %8. Okay, so that's my workflow. Does that make sense to people?
It makes sense.
Yep.
Yeah.
Right. So this is what we have to clean. This is what we want to have, a really nice way to
So,
do this.
but there are other, okay, so let me bring up not just your particular case,
Mhm.
but I think that sort of there are two things. As we get, sort of less scientific data and more social data and other things, it gets noisier and noisier. And so you sort of rarely even want to see interpolation between those points. Those are points, and you might want to see a curve through them that's modeled. Now,
That's what I just did.
admittedly, yeah.
That's what I just
But
did. I mean,
yeah, but if you have something more realistic, there's not going to be like a
well,
line
you know
or
what?
something.
I've done this, Roger. I've done plenty of this stuff in real life, right? The fact is, if your data is such a mess that you have to be using, the little tiny thread of a p-value to get anything out of it,
No, okay,
it's
stop
probably all
talking.
nonsense.
Stop talking. Okay, so then you want sort of quality, so now you brought in a different thing, which are sort of indicators of the quality of the fit. And the number one visual quality marker is probably confidence bands. And so we got to get those out, and it's got to be easy to plot them and show those bands.
I think you're solving the wrong problem.
No,
I think
not.
you're solving the wrong problem. I think that those things are good, but they are the icing on the cake. The
Yeah.
number
So
one thing
with
that we
the so
need,
uh,
the number one
we
thing we need is people have fairly clean data and they want to frigging fit to their data.
yeah.
Their data might be exponential, their data might be this, their might be data might be that. And yes, you're right that they would love to have in here plus minus whatever. They'd love to have round numbers here, for example.
No, I don't know about that.
Well, I can tell you
I
that
mean,
they would like that.
yeah, there's that the things for the parameters. Sure, absolutely. But you want it for the curve, and those are different.
Yeah, I agree. I agree. But I'm saying the 0th level thing that people want is the thing I just showed you. There's lots of elaboration of that. I agree. There's also a corner of the
we
space.
designed a thing where you can use simple models. If it's something more complicated, you have the full capabilities of building that. And
Okay.
you're gonna have to use show them because you're gonna fit the model, you're gonna use the model. But then
So
you
what,
get the
let,
full
let's
strength
let's
of
figure out how this works.
fit.
But I just want to say, just in terms of understanding the space, right? There are two directions that one can go. One is data that really doesn't show squat, right? And plenty of people have that, and plenty of people produce fits to data that doesn't really show squat, right? It's a sad but true fact about science in quotes or whatever it is,
I
particularly in.
think that if you see a curve through plot for points, that helps you understand the points,
Oh, I
you know,
agree.
as
I
well.
agree. I mean, it's like,
So,
okay, we got this, and it's like, oh yeah, there's a trend there, you
well,
know,
you know.
right? And then we've got, this, and it's like, really, is there a trend there? I don't
There's a
know.
trend, but how much can you pin it down?
Well, yes, but I mean, in this particular case,
Sorry, I was looking at the one above it. Sorry.
yeah, that one there's a trend. This one, it's pretty marginal. But the truth
Mhm.
is, there's a lot of data out there that looks like this, where people draw trend lines through it.
So the thing we should have migrated to long ago is to not use interpolation and use approximation um, for noisy data. That's how you kind of get
Yeah,
insight.
fine. But
Um, and so that's what the local fitting does.
yeah, all right,
That
okay. But
allows you.
that's
It's going to be as useful as interpolation. We use it
great.
everywhere.
Great. It
Okay.
sounds like a fine thing. But the thing that I'm concentrating on is the workflow of going from a bunch of data points to get to this and the
Mhm.
data behind this.
Yeah. And so
Explain what you mean by the data behind that.
What I
yeah.
want is, and I don't know how to do it, right, which is why we're having this meeting,
Hmm.
Mhm.
right, is I want to be able to easily go from this here, right? I've got this data. I
Hmm.
want to be able to easily go from that to extract, you know, this thing, maybe with round numbers and so on,
Hmm.
and go from, from this. And what's difficult here is it's a little bit of a kind of a I want two things to come out type thing. I
Yeah.
want both the graphics to come out and I want the
I mean, we if we look at step by step, can you open the documentation for find fit and fit?
well, I
Because
mean
we did
they're
some
different. I
updates
mean,
to.
but
I mean,
yes,
here is the
I
solution.
know,
Okay. Here's
but
the
we
solution
did
for
some
your workflow
updates to
problem,
fit.
Stephen.
Mhm.
Okay. You may not like it. Okay. But here, let's say that there was a fitting function.
mhm,
And what it produced is some composite object, which includes the function fit, the uncertainty bands, and the data is still there.
yes.
Then it has everything it needs, and we can kind of it's a one stepper from
I
there.
like it. I think that's a good thing to have. I mean, I think it's like interpolating function. It's a fitting function of some kind.
Okay. What we did with fitted model was along those lines, but it doesn't go all the way there, and it's missing a bunch of stuff. Like confidence band are super important.
Yeah.
I
Right.
can't
But I
tell
mean,
you how
so
important they are.
okay,
Now we have a bunch of other indicators or biomarkers, or what do you call them, confidence markers, which people are fond of and not fond of, and people have opinions about them. I don't know how much you use Akaike information criteria. Probably never.
yeah. I
Okay.
mean,
But people like some, and we have a slew of them. And you might need
I
them for a
agree.
report.
Yes, I agree. But I mean, so look, the general direction of going to a fitted function or fitting function or something, which, like interpolating function, contains the data. I like that very much. I think that's the right direction. And being able to go,
So we
maybe,
we, we,
yeah,
we are producing something that's along those lines now, but we didn't include the data. But if we include the data, then you have everything.
I think we should include the data, just like interpolating function includes the data.
No,
Right.
Roger, we do have the data in
We
the local
do?
model. Of course. How can you? I mean, we have design metrics.
Well,
Otherwise,
that's great.
how
Then
can you
we
fit?
then we actually have everything. But then we have to go back to all the other functions that Stephen wants.
Yeah, right.
Like
But
Yeah.
we have to backfit that.
let's look at the rough workflow here. Okay. So
Mhm.
we have something which says, let's imagine that we can use, I don't know, let's even imagine that we can use fit. But we probably, that's a bridge question.
Okay, so can I just inject one more thing
Yeah.
before we go to? So remember, we have compute objects for all kinds of things. Like you can have a histogram distribution, and you can use it like
Yeah.
any other distribution. So we have a bunch of these non-parametric distributions that allow you to do a lot of compute. But oftentimes, the only thing you really want is the picture of a histogram. And so we have dedicated such functions.
Which are what?
Like histogram
Histogram.
draws a histogram.
Yeah, okay, fine.
There's literally a
But
dozen different variants of it.
The fact is, I should have used histogram distribution a bunch of times.
Mhm.
I haven't. It's not appropriately part of the workflow that I use.
But we built it so that it works like any other distribution, which is
I'm well aware,
amazing.
right?
Kind
Right.
of cool technology,
I
the
think
whole
it
thing.
is very nice. Yes, I think that is nice. But
But what we also realized is that people often only want one thing, so there are these, and also we couldn't do as good of a job to plot these distributions if we didn't have a dedicated viz function. In fact, what you complained about the other day when it comes to showing these bars and things.
sorry, I got distracted for a second. Could you say that again? I apologize.
Yeah, so this histogram distribution, it has a PDF that is basically a piecewise constant function.
Yep.
And those don't draw nice, okay, unless you have sort of a dedicated plot function for them. They
Yes.
just don't draw nice.
I mean, look, one of the issues that I ran into, which I was making a fuss about, was list step plot. Okay. First of all, let me give you the following example. Okay. So let's say I have, list step plot of range of 100. Let me do this. Let me show you what goes wrong. Okay. So the range of 100. Now let me just go and start erasing some numbers here. Okay. And then let's say
we have
list
an
step.
extra comma somewhere. Fix the extra comma there.
Yeah.
Then we're good. Actually, we're probably
I
working
was going to say that would have, shown
Yeah,
one of
we
the
deal
things
with
that we
missing
zoom
data.
into.
No,
Okay. Oh, this didn't do what I expected. Okay. I was trying to get things that look what I really wanted to do. Sorry.
If you had left the extra comma in there.
No. That's not what I'm
Okay.
I'm trying to show, I don't know, let's say this is not really what to do, but bad. Sorry, it doesn't. I should do this for like. Okay, so the misleading point here is that's what I would like to do is to make this into something like a bar chart, like a histogram, right? Where first there are two issues here. One is that point there is missing, right? 13 is missing.
It is not. Well, okay. The
It
point
is
is missing, but
Okay, so the issue that I've had is that if this was a histogram, right? If I made a histogram and there was data missing, it would go to 0 here, right? This is a plot
yes.
where it doesn't, okay? I mean, I nearly made a nasty mistake yesterday because I was using list step plot to basically fill in a pseudo histogram, if you understand what I'm saying.
Mm-hmm.
And I had a thing where it was just flat, but that was actually wrong. It was going to 0 there. And so there's so that's one thing. The other thing is I'd like to be able to take this and I'd like to be able to make it to make vertical, to make it look like a histogram plot. You understand what I'm saying?
Right. I understand you wanting it to make it look like a histogram plot.
And so how do I do that? I mean, if I
we
say
discussed this yesterday afternoon. There's not a way to do it right now.
okay, but I mean, but also this thing which I hadn't realized is this thing about make it go to 0. Okay, this is a separate thing. So I hope somebody's.
It's a separate thing, but list step plot is doing exactly the right thing for the data that you gave it.
No, I don't disagree, but it's not doing the only thing that one needs it to do. Okay.
Right.
Okay.
If you
So okay,
had
let's get
like,
off this topic
13
because
something that was missing.
right. Let's. Well, okay,
But
fine.
anyway, diversion.
Yeah. Yes, if it was explicitly missing, then that's one thing, but just not okay. There's a confusion here. Okay. Now, sorry, let's come back here. To me, histogram distribution is a great idea if you're thinking about statistics. I should have used it in a lot of kind of fits meets data, but I haven't.
Well, you can generate random numbers from it and all kinds of things.
I know it's great, but it's in the statistics workflow, but it's not in the visualization workflow, in my mind.
Well, we build dedicated functions, as I said, because that's usually what people want.
No, I understand. Okay, so let's come back to what we're talking about here. So,
if you go back to the top, Stephen, like one thing that one problem you pose here has been addressed by adding properties to fit and find fit. So if you do that find fit, if you do comma after x, comma best fit, which is the same property that we have in nonlinear model fit, you get the function you want without any replacement or stuff like that.
Wow, I didn't know that. Nor did our notebook assistant.
Well,
This is
you
documented.
asked for that, and we did it. So,
Yeah. Well,
now
how long
I
ago?
think last version.
Oh, okay. So I'm not that out of date. That's nice. I'll use it all the time.
Yeah. Now there's still one thing here. Like we have basically two slightly disjoint. I mean, like from the outset, they are disjoint families of fitting function. Yeah, which is fit and find fit, that are more likely like workhorses function. When you ideally just want to get fit out, you don't care about much else. Yeah, and then like linear model fit, non-linear model fit, generalized linear model fit. Those are giving you the fitted model. Yeah, that is something that you are doing. If you want to do statistics, ask for like criteria, properties, confidence band, and such. Yeah, so they have like different goals. Now, this is a little bridge between the two, yeah, because you are having like some.
Right. So look, what we need to
are,
do, in my opinion, is go all in on I like the idea of a fitting function or some such other thing that everything returns. Okay. And from that fitting function, you can extract the statistical data, you can plot it, you can do all kinds of stuff.
Fitted model already has most of that.
Yeah.
Here we are talking to expanding that to do some extra legwork for like local model.
How do I get this? How do I get the fitted model analog of this?
Copy that and replace find fit with nonlinear model fit.
Yeah, I mean,
the syntax is exactly the same. Yeah, so this thing has if you do properties of that thing, you see what that contains.
Okay, it's great.
And we could, in principle, add more. Yeah, we could add, as Roger was saying, like we have the confidence region for the parameters. We don't have the. I mean, we have mean prediction bands.
Okay. We can fill it out, and we should. But this is indeed close to what we need. I think it just needs some design. What the heck is that?
It's the diagonal of the hat matrix.
What that is, but anyway.
I don't immediately remember why that is useful. Sorry.
Okay. Doesn't really
but
matter.
my background is not strictly speaking statistics, so this is why I can.
Okay.
But yeah.
This is good. I mean, its name shouldn't be nonlinear model fit, even though that's a lovely brand name that I see people use in papers and things like this.
It's a popular function. It's one of our most used functions.
Yeah, I know. But
I mean, this is one generic thing that I brought up a couple of times to Roger, but the point is that we have legacy here. Yeah, is like you have basically two choices here. Either you have specialized trainers and a single.
Julio, can I tell you something about our design principles?
Please.
How many thousands of times this has happened, right? Let's figure out what we want, what the right way to do this is. Then let's figure out how we make a bridge to what we have right now. Okay?
Yeah, okay.
We're not going to be looking over our shoulder and worrying about whether we have, this plank that we step on or that plank we step on. See what I'm saying?
Okay, no,
I don't wanna hear
I'm already
that.
telling you. I'm already telling you what I see. I see two ways here. One is what you have right now, like a family of trainers or fitters or however you want to call it, optimizers. Yeah, depending on how in which field you came from. Like non-linear, linear, generalized linear, logit,
Whatever.
probit.
Yeah.
Yeah,
Okay.
and the return model is the same like, internally that it's written there that is
Yeah,
linear or
I
non-linear.
got it. Yes.
Yeah? The alternative is that you have like a model fit function, yeah, and then you feed in like a linear model, a non-linear model.
Okay. I get it. I think the answer is
Yeah.
obvious. Okay. Look, here's what should happen. These things that you know you want a nonlinear model fit, you want a linear model fit. Okay.
Hmm.
Let you use those functions if that's what you know you want. If you don't know anything and you just want a fit, then then we need a function that is more or less, and I know our function fit right now. Let's not worry about its syntax right now. We'll figure out the bridge later. Okay. But in the end, it's like, just do the right thing type thing, where it's up to us to decide, do you want linear fit? Maybe it's using one of these, AIC things or some such other thing. If it's close to like in this case, if it's like, I just want to fit, right? This would be a good thing to give a linear fit to. You probably don't want a fit that goes wiggle, 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 wiggle here. See what I'm saying? And that's a heuristic which in modern machine learning times, we should be able to do reasonably well on guessing what is a reasonable fit to data.
Okay, so you want automated model selection. Yeah,
I do.
something like time series model fit is doing that, or predict is doing that, but for like more code-based model. So you want like something like predict, but for an actual formula model.
Right, that does okay. And it's similar to, find formula is sort of a slightly similar thing, which doesn't work so well yet. But the basic point is, for many people, it's like, I've got that data. What's a reasonable fit to that data? The data is exponential. I want an exponential fit, etc. For me, a lot of times I look at this data and it's like, yeah, I know it's a linear thing. I can't be bothered to go and, yes, I might remember it's a linear model fit or, whatever, but just give me the obvious fit, similar to the machine learning story, right? Except that here, like with symbolic regression, you get to see the fit. So it's a little bit more, in your face what happened. Whereas with machine learning, there's a black box that's created and you don't know what's inside it. And so if there's mess inside it, doesn't matter so much. Does that make sense? I mean, to me, what should happen here is,
I think it's a new function, Stephen. I mean, fit is such a.
I don't care. I don't care.
Fine.
Let's not,
fine. So that
new fit. Okay, let's call it for now. We'll worry about the bridge later.
Okay. So I think, I mean, we've been talking about such a function for a bit. Okay, and we, we plan to build it, and so exactly what Julia said. That involves model selection, meaning that you're going to fit many models and then decide or select.
Potentially, yes.
Right? Okay, but often we built a few functions like that already. One is for time series model fit, I think, and it can search hundreds of models.
Yep.
It fits hundreds of models. But you can also, there's like a naming scheme, so you can name subfamilies of models.
Sure.
So if you which is usually you might have an idea.
I agree. I mean, look, I think that being able to say new fit and then being able to say, okay, it's going to be a linear fit.
Yeah,
exactly.
Or okay, it's going to be
polynomial,
an exponential fit.
Something like that. Yeah, exactly.
Yeah.
Or power law. These are
exactly.
Me,
yeah, that's exactly what
ones where I would, like within the last 24 hours, I was fitting some power law thing.
No, it's fine. Then we're on the same page. Which is exactly we're not building that right now, but that's we'll be able to build that.
Right. Okay. So there'll be a whole collection of named models, basically.
Yeah, families. Okay.
Right. And which could include things that are more, that could segue.
So for instance, there are many. So here's an example. Sometimes you model growth. Okay, there are many growth curves, like sigmoidal growth.
I was
and
exactly going to bring this up, like a Gompertz distribution.
Exactly, just like that. Okay.
Right.
Okay. So there's a whole family of those. Another thing, there's a family of things of periodic things. Okay.
Yeah.
Another family of things are basically spikes, okay, like a Voigt distribution,
Yeah.
those kinds of things, like the outcome of a spectrometer or something.
Yeah, right. So I mean, these are
Okay.
things where just like we have modeling of distribution.
And each one of those usually do have a company behind them doing that,
Yeah, right. But
actually, since we
okay.
talked about that.
Yeah,
So
right.
one interesting thing about this is this goes very much in the direction of the other workflow I was suggesting before, because like imagine that instead of just a string, you put in a list of things. Yeah, you could get, what's the best? I'm a bit unsure. Is it better to
No,
use
that's good. That's nice. I
linear
agree
or
with you.
yeah?
I agree.
And then this brings the other question: should we surface some of the machinery that you use for this? Like, for example, something that Sure did in the function repository is a cross-validate function, something that we don't have in top level. Yeah, like something that.
What does it
I mean,
do?
you need to do different fits and then check them against the data and see which one is the best. Yeah. So
that seems like a useful
also makes
thing to
sense
have. Yes,
as
I
an
agree.
outside function, because
Yeah.
you could have used that independently with a model generated by Predict, one generated by something else.
Yes, I agree completely.
Yeah, I mean, that's manual cross, but I think we should
Exactly.
have it. Validation is a very important step, which we don't directly support.
Let's go through what
And
we
it's
think
absolutely necessary for
right.
selection.
Let's go through what we think the flow is going to be. Okay. So
Mhm.
roughly, you've got a bunch of data here. And by the way, this could also be a tabular. And so this could be something like, what we should be supporting here is, new fit of tab, arrow, uh,
List of
length.
strings type stuff.
Yeah. Tab arrow
This is
length, tab arrow width, something like this, or whatever it is.
wait. What is that? The input or the output?
That's the input.
That's saying that we're
Uh,
fitting this. We're fitting that's X, that's Y. We're making a fit. Okay. And then I want to know, a Gompertz fit to this, let's say.
Okay, because right now in like nonlinear model fit, linear model fit, we do support tab arrow width, meaning width is the outcome and all the other columns are the inputs. Yeah. So it's like predict, classify is using the same syntax. So
Okay.
you are suggesting here that we create something where you also like separately indicate the
Well, we're trying to fit the
X values.
XY pair, right? Now,
because in general it's X1,
understand
X2,
your
X3.
point.
Yeah?
I understand your point. You're saying that you've got a tabular where it's got 100 columns, and you're
Mhm.
going to use all of those 100 columns, right? So I suspect what we want for that is something like, I mean, then I just don't know what you're plotting and things like that. I mean, it's like tab, arrow, output, and then the input is, I don't know what it is. It's automatic. I don't know what it is. Something like that. Tab, arrow, all, I don't know. You see what I'm saying? Where everything is going in, but I think it's a slightly different, because in this case, what I expect to get out of this is something that says, well, I don't know how we represent this. That's another good question.
But shouldn't we use the same syntax that we have in plot?
What we want is something that says, sorry, what were you saying? What?
In plot, we have a slightly different syntax. You don't specify tab twice. Yeah, you give it as a list of lists.
Okay, fine. I agree. Okay, so
Okay.
but look, I don't know the syntax here. We have to figure it out. But
Yeah.
the basic point is that what you're saying is you want a version of fitting where it can snarf in, huge it can snarf in all those columns of the tabular. But what does it mean to have a fit then? What does that mean? What are you going to bring out? What are you going to get out? Because to my mind, a fit is like something where a limited number of things go in, a limited number of things come out.
Yeah, it
What
depends.
do you have
like
in mind?
it really depends where you're coming from. Like you like from machine learning could also be that you have like each column is a feature, one column is the outputs.
I know, but that's not what fitting is. What do you mean by fitting in that case?
No, it is fitting. You can do a linear fit using all the columns or the columns plus the combination.
Where what you get out is a function, a linear function of 100 variables. Is that what you mean?
Maybe even more if you want the interactions.
Okay,
You,
I
you could
understand.
do
Okay.
then model selection and drop the one with very low coefficients, for example.
Okay.
That's also
Okay.
something.
So what you're talking about is a bit different from what I'm talking about. What you're saying is sometimes you want what one might call big models,
Yeah.
not large language models, but large data
Yeah.
models. Okay.
Yes.
And so I think that's a slightly different end of the story. So I mean, there's like small models, there's large models. Okay. By small models, I mean things like, y equals 2x plus 3.
Yeah, I understand what you mean perfectly. Yes.
Right. And I suspect we need slightly different functions. I mean, the same functions will handle both of these, but we'll need the ways that we make use of these things will be a bit different.
But you're hitting an important point here that like we lost a lot of nights over with Roger or mornings, depends on where you are in the ocean. Is like specifying the model when you have a tabular. Yeah, because you said X, Y, yeah, but then the tabular will have column names.
Yep.
And then you have two different ways of talking about things without doing crazy thing, as you said, like string arithmetics, like staying in the normal realm. We have functions and expressions. Yeah, like if you want to plot stuff, you want to stay in the expression realm, X,
right,
Y, Z.
Yeah.
For tabular so far and data science workflows, we have suggested the function workflow, like hash column 1, hash column 2.
Yep.
So those are all something that needs to be kind of subsumed.
I know. We have to unravel all of that.
Exactly.
I mean, I mean, I don't think this is right, but one could imagine something. This isn't right. Okay. I mean, this isn't right. I'm playing around with what does the variable look like? That is, what does the thing look like that represents that column, so to speak? What is the symbolic version?
Yeah.
What is the symbolic representation of a column in a tabular?
Do you want me to throw you another curveball here? What if year is not a numerical column, but is a quantity or a data object?
Yeah.
Then your wrapper needs to also take care of the numericalization. Yeah, you have a little feature extractor basically inside.
I don't think so. I think what should happen is, I think our functions on the outside, the fitted model thing should be able to deal with quantities. I mean, it can do it. Its innards probably won't deal with quantities, but just like tabular, it should have a metadata layer that quantifies things and so on.
Okay, so when you extract the function and you look at the expression and you look at it, that thing will only work with numbers. Because if year is not a number, then it's useless to have data year, because at the moment you apply it to the tabular, it will fail because it will bring in it.
What?
Like your symbolic wrapper here is saying this is a variable that takes values from the year column.
Yes.
If the year column is a date object, and this thing expects to return a number for your model.
Why would you expect to return a number? I mean, it shouldn't. I mean, these fitting things, they should segue into time series fitting, just like tabular can deal, just like list plot now very nicely can deal with data objects, right? So should the fitting functions.
Yeah, but I mean, fitting functions already deal with time series. I don't think it's an issue. Any specific thing is not an issue. What I'm concerned about is the generality here.
Hold on. I mean, I think we need to come up with some prototypes. But the thing is that if you have a function that expects a data object, which we can now generate, we can fit such functions. They expect an actual data object as opposed to like a real number. Then we have a bit of an infrastructure issue. Like there's more in our infrastructure that need to work well with data objects.
Yeah,
like should plot, for instance, be able to take date ranges?
It should.
Right. So there's a few things that follow, I think.
Yeah, I know. We should work through those. I mean, like plot taking date ranges is a good idea. I've needed that. I've sort of wondered if it worked. I tried it. It didn't work.
Right.
Okay. It should have worked. I expected it to work. An LLM would expect it to work. That's my test these days.
Yeah. And I think we have more such things. So tabular, I think, has been good to us, in that, I mean, it's not that we didn't introduce data types before, but tabular sort of drove the point home much more. And so I think we're crossing that categorical dates and now geopositions, things like that.
Yeah, and I like the work with categorical data, which has also got to flow into this. But let's talk a little bit more about this workflow, okay,
Mm.
and what it looks like. All right, so basically there is a new fit function, and there are specialized fit functions. If you know it's linear, blah, 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 which are equivalent to new fit with a linear, you know, with a thing, but we're not going to have every one of these isn't going to be its own function. Some of the prominent ones might be like linear model fit, nonlinear model fit, and so on.
Right.
The return result from this will be something like a fitted function, which is very similar to fitted model, might be fitted model, I don't know yet. Okay. Then the next thing that I think has to work is, how do I take that fitted model and put it in this list plot? See what I'm saying? So in other words, let's say I get the fitted model out.
So let me interject a little bit with what part of our design is that we're working on. So
Okay.
part of it is an option for the data viz functions.
Yep.
Tentatively called like plot fit.
And in particular, they can take a fitted model or
I
fitted
get
function.
it. I get it. I get it.
But
I mean,
also,
yeah.
you would be able to say plot fit goes to linear, and it would draw the line.
I understand.
You wouldn't get access to the actual model in that case.
All right, so let's look at the workflow then. Let's look at the workflow. We've got data, and so we let's look at our workflow. Okay, so we've got data, and one thing we do is we say new fit of that data, and it gives us a fitted, whatever it is, a fitted model or some such other thing.
Some sort of fitting object, yes.
Right. Okay, and then what we say is we say list plot of data, and we say
plot fit goes to %.
I don't really like the term plot fit, but let's use it for now.
Yes.
Okay? Plot fit goes to this thing here, to fitted model. Okay, the alternative would be, and the fitted model, when you did this, okay, so another version of this would be, let's say, Gompertz here, right? And then the alternative would be in here to say, instead of fitted model here, to say quotes Gompertz.
That's exactly what we've been doing.
Okay. I like it.
Okay, but we haven't built this big function yet. I mean, I have meta plans for it. So we'll build it, but we can't.
Okay.
It won't come up next week.
Yeah. Okay. All right. Fine. So, but let's just understand. So then, I mean, something like, this is a bad name, but fitting display arrow. And then that says, is it confidence bands? Is it this? Is it that? Is it just the line? All those.
We're working on exactly that too.
Yep.
Okay. Good. I always like it when the design that you guys already have is the design that, whatever.
Yeah.
I don't know what this is, and I don't think I'd ever use it.
No, it's not.
It's
no,
a
no, no.
prototyping stage.
That's a wrong name.
Okay.
So, but it shows a different type of. So one thing that this shows. So we're working on different display. I think confidence band is the most important. This is a different display. What that shows is what's called the residual, the gap between the data point and the. Okay.
But I think I mean, what this is, one of the things that's notable about this picture is the data has receded into the background, and the main thing you're showing is the fit.
Yeah.
Right?
Yes.
So I agree that that's an interesting case, and maybe that deserves another function, because in a sense, list plot is a data first function, and the plot fit plot, whatever that thing option.
Well, we figured we would have a few of those. So, we're working on 2 right now, which is list fit plot 3D. But there will be an option for a huge set of functions to have this.
No, I understand.
But I don't think we should build 100 new, plot fit
I
functions.
agree. I just want to say some things that, like scaling function
Yeah.
to my mind, has been a big success. I use it all the time. It makes sense. I put it into different functions. It's good. It's very
Right.
general.
Yep.
I think
And
this
this is
idea,
similar.
yeah,
This
right.
is similar.
Well, I like it. I mean, but what you're saying is, to my mind, what we've got is, there's the data first functions, data first visualization, which is, list plot and all those things,
Mhm.
right? And then the question is, do we make it as do we make a family of functions that are a function, a fitting first visualization, or is that an option to list plots? Do you see what
Well,
I'm saying?
my goal was to do both. We at least we want to showcase some of them. That's an option.
Predominantly the first, a few of the second.
Yeah, the first one is the vast majority is that
No, I mean, I like this idea, and I think this is useful.
Right. I mean, and to some extent, it may be a difference between list plot and list line plot with the fitting option.
I see what you're saying. I mean, list line plot, I consider to be successful. Like, we could have just done that with a joined option, but it's useful to have that be a separate thing.
I mean, we did it with a joined option for 20 years.
Yeah, I know. So, I mean, so this is, so, that's a good model, I think, is that the simplest case we put in as a separate function. So, for example, I don't like the name here, but this kind of
Yeah, if
you
it was
know,
list fit plot or something.
yeah, list fit plot isn't terrible.
It's short, gives you an idea of what it is.
Right. Yeah. I mean, where that's going to mostly show you the fit, and by default, it'll probably show you these residuals.
Mm-hmm.
I mean, again, honestly, that will be a function I would use all the time, I think. But
Yeah.
it would need to be the case that whatever list fit plot does, that I should be able to do new fit of that data and
Yes,
get out.
that's exactly what we're work. I mean, we don't have the function that you described here now. It's been
Yeah,
kicked
right.
around, but okay. But we have what we're working on is that the ones that we have will produce things that can be used.
Right. So I just want to understand in the case of, a fitted model, and I don't know how this works right now, but if I take that fitted model
Mhm.
and I put in 5.6, okay, that works. So that really is like a fitting function.
Yes.
And how do I get out these properties? Is that a hackaroo? I mean,
Yes.
that's a hackaroo.
Yes. I mean,
Some kind of marsupial that was might have.
it follows what we have been doing all along, so.
No, this was a thing that Rob introduced at some point, and I hated it. It was introduced for interpolating function. I remember. I was not keen on it. And of course, it's going to bite us in the nose when we try and do categorical data here, blah, blah, blah.
No, I think there's just a very finite list of strings that are special.
Yeah.
You just hope that you don't have properties as one of the
Yes.
things
Or
that
data or lots of other things. It's just not a great design.
If I want to use a symbol named symbol, I'm in trouble.
Yeah, right. Okay. It's not a great design. But this is a I mean, I'm trying to think. I do think that new fit, look, I think the goal should be whatever new fit is, and whether we make it be compatible with find fit or a different thing, I don't know. But that should become the fitting function that we point people to. It's
Yeah.
not like, oh,
No, I think so too. I think that can be significantly more consumerized and just way easier to use.
right.
And
So I mean,
very reliable too, because
right. But okay.
those,
Okay. So fundamentally, new fit returns a. I mean, the thing that's bothering me, okay, is so one thing I don't understand how to deal with the thing with okay, so what are some known problems? Let's just list out our known problems. Such a messy notebook. Okay. Naming variables for columns in tabular. one
We have a
unsolved problem.
preliminary solution. I don't like it, but it works, which
Okay, well-
is that when you list the variables, you can point to the column names from the variables.
Okay, I need to understand what you're saying there, but okay, let's just list our known problems. The
Yeah.
next one is extracting properties from fitting functions. Okay, and you know what we've done elsewhere often is to say information of blah 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 comma property. It's not my favorite, but that's a way to do it. See what I'm saying?
Yeah.
And it depends on the use cases, because if the thing is like, you know, like the R squared or something, it's, you know, some of these things, it might almost be the case that one might want to say R squared of either data or R squared. I mean, I don't know, this is you know, R squared of model of fitting function. That's another possibility for some of the more common ones. I don't know if that's a good idea, but that's a possible approach. So tell me what your solution for naming variables for the columns is.
Well, so if you take linear model fit,
Mhm.
tab, comma, model, comma, list of x's, x1, x2.
Linear model fit of tab, which is a tabular, yes.
Yeah, comma, model, comma, x1, x2. A list of, you know, x, y. Okay, so then you say point x goes to string, or I guess you could do it that way too, but you can map the individual variables to the strings like this, you know, and those refers to the column names in tab.
And then you could say tab goes to speed on in the first argument to also get the output. You need to decide what the output is at this point. Yeah.
I get it.
So
let me see if I understand this. So if I'm much more familiar with find fit here. So let's look at find fit.
it's exactly the same syntax. So
okay, but hold on. Normally I would have data here, right?
Yeah.
And data would be like XY pairs.
No, it's like x1, x2, x3, x4, y in general.
Right. It's like a matrix of columns, you know.
Well, there's the question of what the fit
they,
function takes in should be like the machine learning functions. It should be very forgiving. It should allow associations and this and that and the other.
Yeah, we did the update for the model fit family. We would need to backport the parser for fit and find fit.
Yeah, okay, fine. But just so I understand, the let's see, what am I putting in here? I'm putting in here why am I not putting in, okay, so I've got inputs and I've got outputs here. Is that correct? I mean,
yeah, and in the future, there will also be able to be multiple outputs. So that's also something to remember. Right now, you can only have a scalar output.
I get it. Right, but so to me, just like in classify, for example, I mean, normally in find fit, what I have is a bunch of x1, y1, x2, y2, correct?
Correct.
Okay. So
and those you can see them as columns. There's an X column and a Y column.
I get it. So now we had a way syntactically to make it work, to have the whole list of x1, x2, blah, 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 and the whole list of y's, did we not, without transpose? We have a way to do that in classify. We can do that. Yeah, in classify we can do that. We say a bunch of inputs and a bunch of outputs like this.
Only yes. So if you open the page for linear model fit, you see what's our parser for like our parser for fitting functions, which is like heavily inspired about what you have in classify. This should cover, like if you open it, the first table should cover, I think, most of what you need here. There. Oh no, we don't have the association one because we were waiting for the model thing. But yeah, this also works.
Okay.
So you
here,
could argue that the default syntax is the one with n being -1. Yeah. So by default, the last column is interpreted as the output.
well, I see that goes along with this.
Exactly. So the tabular name is a generalization of that, basically.
Right,
And
but the
we
question is
lifted
which-
those two from predict classify.
Okay, so the only issue here is to get the syntax to deal with in here, right? So you've got the concept of a new fit of tabular arrow output column, right?
Yeah, exactly.
But what we don't have is the syntax for these are the input columns and that's the output column. And I would like to suggest that the way to do that is something like this.
What are we doing, Brett Roger, for the 3D plots where we have more than one input column?
It's a list, but it isn't distinguished between domain and range, which I think you want to do here.
I would suggest something like this. Maybe this isn't quite right, but something like this, and that will generalize nicely to multiple outputs and so on.
Yeah.
The
If you don't put the other
second rule
bracket,
is rule or comma?
No, this is
no.
this is a parenthesis. This is
Oh,
not
is,
a list.
Yeah.
sorry. I was
If you
sitting
don't
back
put
from
the
my screen bit.
parentheses, what's the default grouping? Do you need them?
The default
Correct.
grouping is the
I-
same. It's just easier to parse visually with parentheses around.
Okay,
it.
because I always forget what's the precedent here.
Yeah, no,
Okay,
it's
cool,
correct. You can do it. You can
Okay.
just do it.
Cool. Okay.
But I mean, which I think is pretty nice. I mean, it's the tabular, and then this goes to that. Now, the thing that's much less obvious to me is in the output. How is it represented? Because that's where you need that data of blah 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 thing. Because in other words, the analog of best fit, right, which is supposed to name the nth column, supposed
Yeah.
to name input 1 and so on. What does it actually use there?
Yeah.
Now, again, we get a little bit of extra freedom because you're not typing it. See what I'm saying?
I mean, could you
Yes,
just
I mean,
use key?
here you are using it. No, because not if okay. Up there we have best fit. Can you copy that thing and replace function in place of best fit? Because I think it's useful to look at the two. Okay, so this thing here generalizes immediately to tabular. The one above, how do you imagine to use that? Yeah, this is an expression, so this works well with like dissolve, plot, stuff like
I
that.
don't know. We've run out of time here. So
Yes, yeah,
let's
we need to
continue.
continue this. But yeah,
This is going in a very good direction. I like it very much. And okay. Anything
All right.
else for right now? Actually, we have another meeting some of you may be in coming up right
Yes.
now. That's also live streamed. So see you, some of you there.
Bye.
Okay. Bye for now.
See ya.